everyone. This week for Trout Thursday, we're going to deep delve into the Chesapeake Bay and the watershed. So you might think, well, why are we focusing on the bay when we're raising freshwater fish in our classrooms? Well, everything is interconnected, and so we're going to talk mainly about the Chesapeake Bay watershed and how everything that we do in both the state of Maryland and also surrounding states all affects not only the bay, but it starts off at our rivers and our streams and how it affects that habitat and ecosystem, and then it migrates down into the bay ecosystem, and then everything's connected, right? That goes right out into the ocean. And so all of the little things that we're either doing or not doing in our sections of the stream is then going to influence the bay and the ocean. So first we're going to start with water overall, okay? There's only a certain amount of water that's on the earth, right? So if we think about a globe and we look at a globe, all the blue on the globe is going to be your water, and then all your different colors or one color based on what globe you're looking at is going to be your land. So how much, if we have the globe, how much of the globe is water? Do you know? 75% of the earth is water. That's a lot of water compared to land. So let's put all 75% of that water into this bottle, okay? Gotta use your imagination, but we've just put 100%, so all of that 75%. So this is all of the water on the entire earth, okay? Well, do you think that all of this water is accessible to us? That we can go ahead, we can drink all this whole bottle, like I get this whole bottle to myself? No. So there's a lot of water that's in the ocean, right? We don't want to drink salt water. A lot of animals can't drink salt water. How much of this water, of this 100% of the water, am I going to have to pour off? What do you think is salt content? 97% is salt water from the oceans. So if I subtract my 97% from my 100%, what percent do I have left? Only 3% is going to be fresh water. So I think I have quite a lot of water that I have to pour out of here, right? That we can't drink because it's in the oceans and it's salt water. So here we go. I'm going to pour that out. We there yet? Nope. 3%. I have to have 3% left over. Still a little too much, I think. Just about there. I think a little bit more though. A little more. Okay. So here is our 3% of fresh water. The rest we've dumped out. Of that fresh water, can we still get to all the fresh water that exists on the earth? No. So there's some fresh water that's trapped somewhere that is already an issue because it's melting. We don't want to melt it more, right? And that's ice, right? We don't want to go to the North and the South Pole and melt all of the glaciers in order to get drinking water. We're already having that issue with climate change and sea level rise, so we don't want to melt it even more. So of this 3%, how much more percent do you think is trapped as ice? Another 2% is ice. So I have to pour off another 2% of this, and we're going to be only left with 1% of water, okay? So pouring. Okay, probably at about 1% right there, right? Okay, so now we have to discuss, is this 1% of water that we can actually reach and get to, can we still drink it all? Think about that. So there's a difference between drinkable water and non-drinkable water. So the fancy term for that is potable, means you can drink it, and non-potable means that you can't drink it. And there's different reasons why water can be non-potable. It might be polluted, it might be stagnant, which means that it's not got oxygen in it and so it just festers all sorts of bacteria, or maybe we just can't quite reach it if it's in a really deep underground aquifer or anything like that. So again, I have 1% that's left of our entire water. How much do you think is non-potable water that we cannot drink from this 1%? 0.99% is non-potable. So if you think about $1, how many cents are in a dollar? 100 cents. So that means 99% is 99 of those pennies. And I'm going to be left with 1 penny, right, from our dollar. So that's the same thing with this. From our 1%, I'm taking away 0.99%. So I'm going to be left with 0.01% of potable water. So what does that look like in our, our water jug here? Let's see. Pour out so I have only 0.01%. That's still too much. There we go. Okay, if you look carefully, do you see that teeny drop of water swishing around in there? A drop. I have a drop to drink for the rest of my life. Guess what though? It's not just me drinking this drop. It's all of you. It's all the animals that live on Earth. We have 0.01% of drinkable water for everyone on this earth. I know that this is scaled down a lot, so it's much more than this drop, but think about, it's not a lot if you think about it overall, right? 0.01%. So of this 0.01% that is drinkable, it would be a good idea for us to not pollute what we can drink, right? So is polluting easy to do, hard to do? What do you think? Think about that. Is it easy? Is it hard? Maybe it's easy for you not to pollute. That would be great. So what we're going to do now is we're actually going to tell a story about just how easy it could be to pollute. So we have this big jug sitting here, right? We are in a Chesapeake Bay watershed. So when we think about a watershed, it's pretty easy if you use the terms to describe it. So water and shed. So it's a place where the water sheds to or runs off to, okay? In the Chesapeake Bay watershed, there are actually 6 states where their water runs into the Chesapeake Bay. And this jug here is going to be our Chesapeake Bay, okay? What that actually looks like, though, is this map here. So we have our entire Chesapeake Bay watershed listed here on the map. So we're in Maryland, right here. We've got our Maryland area here. We have Delaware off to our east. We have Virginia to our south, our West Virginia to the west of us and west of Virginia. Above us to the north, we have Pennsylvania, and then above Pennsylvania, we have New York. Now, let's look at this map a little closer. If we take a look at this map, is this the entirety of New York State? What about Pennsylvania? Is this the entirety of Pennsylvania? Not quite. So if you look carefully on our map, we can see these black lines, right? So that is the black line, is the outline of the entire state of Pennsylvania. Well, how come the state of Pennsylvania up here doesn't go into the Chesapeake Bay, right? So in a watershed, again, it's where all of the water goes to. So all of our streams and our creeks and our rivers all drain into the Chesapeake Bay. Well, if you look carefully, there's a little bit of a white line along the whole edge here. It goes all the way down. Do you have any idea of what that white line could be showing? That's the Appalachian Mountains. So if you think about a mountain, we're gonna draw our lovely mountain right here. Here's our mountain. When it rains, okay, here's our rain cloud, here's our rain. Gravity goes downhill, right? Well, if a drop of rain lands right on the tip of our mountain, it's gonna get dragged down either on this side or the rain's gonna get dragged down on this side. So for our watershed, if our water is landing on these mountains, if it falls on this side of the mountain range, right, this side of the mountains, it's gonna go into the rivers and the streams that are on that side of the mountain. And if it does, that means it's gonna go and follow gravity down into our Chesapeake Bay. So you have different land features that are causing the water to go in one direction or another. So then if the water lands on this side of the mountain, guess what? This area over here, completely different watershed. Now, that doesn't mean that we shouldn't care about another person's watershed, right? But it's a lot easier for us to at least focus on the watershed that is the closest to home and the most important to us, right, directly. So if you look up here, someone all the way up here in New York, if they pollute and throw a piece of trash into the stream, eventually that piece of trash can migrate and follow the streams and the rivers all the way down into the bay. And then once that trash gets into the bay, if it still doesn't get picked up, it's eventually going to flow out into the ocean. Holy moly, who knew that people in New York have to care about our bay because they're still in our watershed? So this kind of just puts it into perspective about how everything is interconnected. And it's not just Marylanders' responsibility to take care of the bay, but these 5 other states as well. And so we have to use our knowledge that we have to explain that to other people so that our watershed gets taken care of, but then also all the different other watersheds that are in the United States get taken care of. Going back to our bay right here. This is our bay. We're going to take this jug of water and pretend that this is our Chesapeake Bay. So how easy is it for us to pollute this Chesapeake Bay? And by us, remember, that's all 6 of us, all 6 states that go into the Chesapeake Bay watershed. How easy is it for all of us to pollute the bay? Well, in order to kind of show that, we're going to tell a little story. So this story is about a boy named John. And John is a school kid. He's in 5th grade. And he's hybrid learning, so he still goes to school occasionally. So one morning, John woke up and he's like, another day, I gotta get up early to catch the school bus to go to school. So he gets ready and he's standing out at his bus stop waiting for the bus, and he looks up at the sky and he's like, ooh, it's kind of cloudy. I hope it doesn't rain until I get on the bus. Well, lucky for him, he ended up getting on the bus just as the rain clouds opened up and it began to rain. So he got on the bus and he's looking out the window, watching things as, the bus passes by. And he notices, man, he made it just in time because now the wind is starting to pick up. And he notices that the wind is blowing all of the leaves off of the trees. And his bus route follows a local river, and he sees all these leaves are getting blown right into the river. Well, guess what? That river goes into the Chesapeake Bay. So all of those leaves are flowing and going into the rivers and going into the Chesapeake Bay, right? So here's our bay water now. It's got some leaves in it. It might have a little dirt in it. Is this water polluted now? It's got stuff in it now. It has to be polluted, right? No, so this stuff is natural. So if you go out to any stream, there are going to be leaves and there's going to be dirt in the stream water, right? And in the bay. There are natural things that are okay to go in the stream and typically will eventually decompose, right? These will rot and turn into soil and everything. Also, leaves make great habitat for our macroinvertebrates that we talked about, right? So that's okay. A little bit of leaf matter going in, maybe a little bit of dirt is okay. The issue is if there's a lot of dirt going into the Chesapeake Bay, a lot of that sediment, it can settle and it can hurt things that live on the bottom of the bay. But right now, we're okay. So John makes it to school. He goes into his classes, and during one of his classes, his teacher is reading about a news article to them about all the different local farmers that are in the area and about this issue that they're having with their livestock. So what is livestock? So livestock is basically any farm animal. You have pigs, sheep, cattle, goats, chickens, all sorts of things that we either use their products, that we eat them, we eat their eggs, we use their milk, or maybe we use for our clothes like wool. And so eventually all those livestock animals have to do what any animal has to do, including us, which is they gotta poop, right? And so if they're out in the field and they're pooping, well, that's okay. But the issue becomes is if they're in a field that has a stream, what happens to all that poop? Eventually it gets washed into that stream. And when it gets washed into the stream, where does it eventually go? it goes into the Chesapeake Bay. So I have my livestock poop right here going into our bay. Yummy. Okay. Well, also on those farms, they grow different crops. And to make sure that their crops stay strong and healthy, they spray them with a lot of herbicides and pesticides. So different chemicals that are killing other weeds and other plants that we don't want, and then also are killing any pests like bugs that might eat the sweet corn or that might eat the tomatoes or different things. Well, what happens is when they spray that on the crops and it rains, it washes those chemicals off of the crops into the streams and into the Chesapeake Bay. So I have all of my chemicals from the farm fields going into the Chesapeake Bay. Okay, well, now let's look at this. Would you consider our bay water to be a little polluted now? Definitely. It's got a lot of chemicals. It's got animal poop, a lot of animal poop in it. And so I probably really wouldn't want to swim in this. Any animals that are living in this might not be too happy. The other thing is that's a lot of fertilizer. Fertilizer is good, right? It helps make plants grow. Now the issue is that too much fertilizer makes certain plants grow that we don't want in the water. So one of those plants is algae. And we don't want a whole bunch of algae to grow because plants use oxygen, right, to grow. If a whole bunch of algae grows, it's sucking up oxygen. And then as the algae dies and breaks down, the bacteria that help to break the algae down also use oxygen. And then what happens is all of the oxygen gets sucked out of the water, and then there's no oxygen for the fish. And then you can have big fish kills where all of the fish die because they can't breathe. So not looking great for our bay, but we're not done. So John finishes up his classes and he goes home for the evening, and instead of doing his homework, he decides that he's gonna go upstairs and play some video games first. So he goes on, he logs on, he's playing on his Xbox, and after a little bit, his mom yells at him and says, "John, you have homework and you have chores to do." Okay, Mom. And so John runs downstairs to go do his chores. Well, what did he do? He left all of his lights on in his room. He left the game running. It's using electricity, right? Electricity. Can we see electricity? Besides like turning on a light bulb, right? We can see that that's happening. But what is electricity? What's it made out of? There's nothing in my jar here. But does electricity still pollute the environment? So a lot of times when I ask where do we get our electricity from, recently a lot of people have been saying, ooh, from the sun, solar power, from the wind power, from sometimes from the water, hydroelectric dams. There's so many different renewable options, but unfortunately still here, electricity is mainly made from fossil fuels. And fossil fuels like coal are burnt. And when that gets burnt, which basically fossil fuels, the reason they're called fossil fuels is because they are old dead dinosaurs and dead old plants that all get smushed and pressurized and packed down. And so we're burning that, and typically when you burn something, right, smoke comes off. Well, when you burn fossil fuels, there's a lot of gases and gross pollution that goes up into the air. Well, what goes up must come down. And so typically that pollution then mixes with the clouds and it comes down as acid rain. And acid rain isn't good, right? If we think of an acid, a light acid would be like a lemon. It's kind of sour. A stronger acid is our stomach acid, right? It helps to break down our food. So acid breaks things down. So if we have acid rain falling on different things, it can break them down, which we don't want. Also, our fish, what kind of pH do they like to live in? They like to live in that neutral pH, somewhere around that 7.0, right? Well, if all of a sudden their pH is becoming more acidic, that's going to be a problem. They might not be able to live in that water. So even though we can't see electricity, it's still polluting the streams and the bay and then eventually the ocean, right? So in we go with our electricity. So John decides that he's going to do a little homework. Okay, he gets his homework done and he's like, oh, fine, I guess I got to pick one of my chores for the week. He decides it's a nice day out, so he feels like, getting a little wet. So he's going to go and wash his dad's truck. He loves it because he loves to use extra soap all over his dad's truck. So he's got soap everywhere. He's scrubbing it, and then he's taking the hose and he's washing the truck off. And all of that soapy water is running down the driveway and into a culvert. And that culvert eventually just empties out into the stream that's next door. Where does that stream go? The bay. So now we got some sudsiness going on in our Chesapeake Bay, right? We're still not done. John then decides he's going to go for a little walk around the neighborhood. He likes to go to this one park and have a snack. So he heads on down the road, and he notices that his one neighbor down the street, they love to take care of their rose bushes. And the person that lives there sprays all sorts of chemicals all over their rose bushes so that nothing hurts the flowers, right? No one wants a rose with a whole bunch of holes in it. Well, just as the farm fields, everything that those gardeners are putting on those roses, all those chemicals, are going to get washed off and run into the stream that then runs into the bay. Extra yummy. All right, well, he finally gets to the park and he decides, okay, I'm gonna eat my snack. He had brought a little container of blueberries with him, and he ate his blueberries, and then he looked around, he went, oh, there's no trash can, there's no recycling bin for me to put this. I don't feel like carrying this home with me. I'm just gonna leave it, not worry about it. What happens to this piece of trash? It gets blown into the stream and then eventually into the bay. Uh-oh, all right. We're not done. We're not done. So he walks back, and as he's walking by, he notices that his neighbor on the other side of his house is having a garage sale. And so they're cleaning out a whole bunch of stuff in their garage, and they come across this canister. It's not labeled. It's just a container of some sort of gross, mysterious liquid. They don't know what it is. They don't know what to do with it. So they just go over to the culvert and they just dump that in. Where is this ending up? This mysterious liquid that we have no idea what it is? In the bay. So he finally gets home and he's like, okay, I've done everything for today. Let's see if Dad will take me out and get some dinner. I'm feeling some McDonald's. So he goes in, he asks Mom and Dad if they can go out to McDonald's. They say sure. So they hop in the car and they're driving, and the McDonald's is in a big Walmart kind of complex. And John looks out the window and he notices that there's a whole bunch of like weird stuff dripping from some of the cars in this parking lot. Antifreeze, oil, all sorts of gross things that cars can sometimes leak. Well, all that leak fluid sits on the parking lot until what? Until it rains. And then when it rains, it kind of gets washed off of that surface and goes into the gullies, it goes into the stream, and then it goes into the bay. All of that stuff. Yum, yum, yum. So they go. He gets his delicious food from McDonald's. They eat, and then they head home. And as they head home, they start to notice that the rain is starting to pick up again. And the wind is picking up. And then all of a sudden, it's like torrential downpour that is happening. Torrential downpour. You ever notice how it always smells and it feels so clean after a rainstorm? Well, that's because the rain is washing all the gross things, the trash, the pollution, everything away. Where's it washing it away to? The streams that go into the bay. Oh, look at this water. Ew, that's kind of gross. Now, there's nothing in my bay here. However, what lives in the bay? Maybe some fishes? So our fishes may be swimming around in there. Who knows? It might be dead by now. And then also we have some of these. What are these guys? These are oysters. Now, these are just the shells. Typically, the oyster is together and the little animal lives inside of there. And these guys are filter feeders. So that means that they suck in the water and they filter all the yummy stuff out. They also filter pollution, though, and then they spit out clean water. Oysters don't move, okay? When oysters are born, they stick to something, and that's where they stay. So these guys are stuck to the bottom of our bay, which is, in this case, looks like they're okay. They might not be able to keep up with all that pollution, though, and they might die. If a whole bunch of dirt went into this bay, though, that would be one of our species that would get stuck underneath of all that sediment and then not be able to survive. But now, let's go back to our fish. Would you want to eat that fish? Do you know where your fish is coming from that you eat, if you eat fish? What about blue crab? Oh, if you live in Maryland, you gotta like crabs, right? Well, here's our fish. Let's say we caught this fish. We're gonna see what exactly is in our fish here. You ready? Ew. We're eating that from our fish because the fish is living in it, swimming in it, eating different things in that water. And that's then what we have left of this fish that we're putting into our body. Gross. Now, I'm not saying all fish is like this. Still eat your fish. But that's gross. We don't want that in our food, right? So with our bay here, that was pretty easy to pollute our bay, right? And that was just a day. That was, how many people polluted the bay? Was it just John? Did John pollute the bay? He helped to pollute the bay. But guess what? He saw so many other people that were helping to pollute the bay. And that was just in his town. Now think about all the people in all the other states that are seeing or doing the same thing. Oh my gosh, our tiny droplet of water that we have to drink now looks like this. And now we can't drink it. So, who's responsible for cleaning the bay? Everyone. We can do so many different things to help clean our bay. And it starts right at home, in your backyard, in the back stream that's in your backyard, or the stream that's in your neighborhood or down the block, right? You start by an easy thing to do. Guess what? Some things are easy. I can reach into here and I can pull out this picnic trash and dispose of it properly. I can put it in the recycling can or in the trash can, right? That's okay. The rest of this stuff was a lot of chemicals though, right? I can't just like suck that out. There aren't any filters that are small enough to get out all of these chemicals. So we have to think about what we or what other people could do differently. Well, the lady that was spraying all of her roses, maybe she could use something a little safer. Maybe she could just pick off the bugs. Maybe she could use some soapy water so that the bugs just can't breathe once it gets sprayed on them. But we put soapy water in here right from the car. What could John have done differently with the car? So instead of washing the car in his driveway, his dad could have moved the truck and put it in the grass, so that when all the soapy water drained off of the truck, it goes into the grass, and the grass acts like a filter. Instead of it being on that non-permeable or like can't be penetrated, right? There's no holes in the blacktop that just whoosh and washed right off. Or maybe John could have convinced his dad to take him to an actual car wash. And at a car wash, all that old soapy gross water gets filtered and then recycled and then reused. Well, what about our farmers? Our farmers with their livestock poop and all their pesticides and herbicides. So a lot of local farmers actually have incentives, meaning that the government pays them money to keep the bay clean. So some examples of that are planting trees around any streams that run through pasture land and fencing the animals away from the streams so that they can't poop in them. Or having another type of buffer so that any pesticides or herbicides that get washed off get filtered out before they hit the water. Or by using not as harsh different chemicals, using other things to protect their fruits and veggies. So eating organic potentially could be a little bit better. Pretty much just knowing where your food comes from in general is a good idea because it affects the environment eventually. And then probably the easiest thing is, what could have John done with his video games, right? His electricity? Turn a light switch off. It's so easy. So while me personally, you personally, might not be able to control everything that happened to the bay, we can start with the small stuff. And every small step is going to help keep our streams and our bay and our oceans nice and clean, right? So that all the animals and people that live there and utilize the bay and the watershed can continue to utilize it, and it can stay nice and healthy. So let's take a quick look at the Chesapeake Bay right now. So each year, the Chesapeake Bay gets a grade, and it works the same way as, a school letter grade does. A's and B's are good, C's are average, and then once you get into your D's and F's, that's not a great thing. So each year, the bay gets an overall grade. Now this one is from 2018, but it had a nice graphic associated with it. So this one's a little bit old, but in 2018, the bay health was a C, and the health of the area was improving. That's what this line means. So if you look at this, each section of the bay is given a different grade, and then the overall grade is taken by averaging all those different areas out. So if we look up by us, like Patapsco area, that's where we are at Irvine. Oh, not good. An F. Ouch. So it is improving as of 2018, but that's red. That is bad. So then we have some C's mixed in. Here's some D's. Then when we get down to the lower bay, this area down here is okay. It's a B. But when all of this mixes together, it doesn't just stay up here. This polluted water doesn't stay here on this branch. It goes and mixes with all of this water. So that's why then all of these averages average out to a C. Now, there are a couple of different indicators that are used to describe bay health. Everything from the actual pollution that we're seeing in the bay, to the water chemistry of the bay, to the animals that live in the bay or live around the bay. And so that's when you have those indicator species. And rainbow trout are a great indicator species, as we've talked about. When you notice that the trout are dying off or that aren't in those certain streams, that means there's something wrong with that stream, and that could be contributing to a bad grade later on down in the bay. We're hoping that we can continue to improve the bay grade. As of last year in October, the bay grade was given a D. Not great. That was an indicator grade of all the different indicators that they were using, said the bay is going to get a lower grade than it did in 2018 if those things aren't changed. One of the biggest ones was actually the striped bass population. That is one of the indicators that's used for the health of the bay, and they noticed that the population of striped bass was down, and so that harmed the overall letter grade. So a D is not good for our Chesapeake Bay health, right? We would love for it to be a B, an A. An A would be perfect, right? But again, it's all the different people that are involved in that letter grade. So it's all about education and kind of doing your part, no matter how small it is, to help to make the bay nice and healthy. So another aspect of kind of pollution and everything is kind of talking about the watershed that we went over, but also thinking about the air shed. So if we said that a watershed is where all the water sheds to or goes to, what do you think an air shed is, right? An air shed is how all the air kind of mixes together. And air is just everywhere, right? It travels different places. So an air shed is so much larger of a space than a watershed is. And we talked about one of the possibilities is for those gases, greenhouse gases go up, they have to come down. They come down as acid rain, or they start to hurt our ozone layer. And so now all these ultraviolet light is coming in from the sun. It's burning things. That's why we really have to make sure we put our sunscreen on and everything like that. So to kind of show how everything builds up together with pollution, we went over our day around the bay where we had all that pollution going into our bay just in one day. but how does it build up over time? So we're gonna play a really fun game that kind of shows how things build up over time. So all you need for this game is some beans of some different colors. So there's some like black beans, kidney beans, whatever, different kinds of beans that you have in here. And then you're also going to kind of pick a food chain to go off of. So our food chain here is we have some cards as an insect, some cards as a fish, and then we have one big predator card as an osprey. You can easily modify this to do your local ecosystem in your tank, right? You can have your little insects, your macroinvertebrates, then you can have a smaller fish species, then you can have your trout being that bigger predator, and maybe then something that also eats the trout. So each person is given a card, and then they're given a certain time to eat, okay? And what are they eating? They're eating their beans, okay? So the insects, or the macroinvertebrates, are the first ones to eat. And what happens is each kid will have a stomach. So this is a stomach, plastic bag, pretty easy. So the insects get to eat first. So your group of insects gathers around their feeding area here, and everyone gets one die, each insect. So you say go, they have 1 minute to eat as much as they can. So in that 1 minute, they roll their die. I got a 2, that means they take 2 beans and put it in their stomach, okay? And they keep going, keep rolling, keep counting, and putting their beans into their stomach for that minute. 3, just gonna do it a couple of times. 1, 4. Okay, so we say a minute is up. Okay, the insects are now done eating. This is their stomach, my insect. Now, who gets to eat? Your fish get to eat. And your fish are eating, not the beans, the fish are eating your insects, okay? Now this is the hardest part because not all the kids want to be eaten. But you gotta deal with it. If someone eats you, you get eaten. Well, how that works is each fish gets 3 die. And in order to eat an insect, they have to roll 2 out of 3 of the same thing. So they, again, have that minute to eat as many insects as they can. They might end up not eating an insect at all, or some people are just really lucky and roll a good hand a whole bunch of times, and they might eat a couple of insects. So I'm gonna roll here. Nope. Oh, there we go. I got 2 3s, so 2 of a kind. So I would be able to, as a fish, use my stomach, and now, guess what? I'm gonna eat this insect. Yum, 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 yum. Okay. The fish have now eaten. Again, if the fish didn't eat at all, guess what? Those fish died. So they're out of the equation. Now we have our osprey. What does our osprey eat? The fish. Okay. For the osprey gets 5 die and has to get 3 of a kind within that minute to eat as many fish as they can. So you roll. Nope. 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 Again, your osprey might go hungry. Nope. They have 1 minute. My osprey probably would die because I still haven't rolled 3 out of the 5. But say your osprey did get to eat, okay? So your osprey has their stomach, the osprey ate a fish. Okay. So now up at the top of the food chain, you have your osprey. Now this, again, works better if you have a whole bunch of kids that you're doing this with, because then your osprey is gonna have eaten more than 1 fish, or your fish is gonna have eaten more than 1 insect. Because then what you do is this shows biomagnification. It shows how things increase the higher up in the food chain that they go. So if you open up each of the stomachs, and if we start with our insect stomach, the insect has to have eaten at least, you can make up these numbers, at least 10 beans in order to have survived. I definitely got 10 beans in here. Well, guess what? If the insect ate 1 black bean Black was DDT. The kids don't know that when they're first doing the game, okay? Now, of course, if your kids are watching this at the same time, now they know, and you might want to switch the bean color. So we have 4 black beans in here. This insect would be dead. So that insect wouldn't even be alive for the fish to have eaten it. Uh-oh. So then when you get to your fish needed to eat at least 2 insects to survive. We're going to pretend he ate 2 insects, okay? So he's alive. But now, if your fish in those insects' stomach ate 5 black beans, then that fish would have died. So then, again, not in the food chain for the osprey. And then when you move up to the osprey, your osprey needed to eat, let's say, at least 2 fish to live. Well, if it did, great, they ate the fish. But now, if they have 10 black beans within their stomach, guess what? The osprey dies too. And so you can do so many different variations of this game, but it kind of helps to physically put in perspective how one insect might be fine. Like this insect over here, maybe didn't have any black beans. So this fish ate one insect that had no black beans, but the fish also ate this one that had 4 black beans. Ooh. So it's automatically building up now. Well, now your fish still lived, right? Because they had to eat 5 to die, so your fish still lived. Well, guess what? This fish over here had another 4 beans, black beans. It's still alive. Well, guess what? Your osprey ate 3 fish, and that other fish had 4 beans in it. That's over our 10 for our osprey now. And so now our osprey died. Even though the insect lived, the fishes lived, but now guess what? Now your osprey died. Or you can talk about it as far as DDT and about how they then would have soft eggshells, and then maybe they would live, but their offspring wouldn't live. So this is just a fun, different kind of interactive game to kind of show that larger concept of biomagnification and how over time everything builds up in an ecosystem. So it's the same way with our streams and with the bay and the ocean. The more that goes in it, the worse it is, right? It all kind of builds up. If nothing's being taken out or changed, it's going to just sit there and increase and increase and increase until we have this giant problem that we can't fix. Or we can start now and start small and start fixing the small problems before they get bigger and harder to solve. All right, so I hope that you guys learned a little something about kind of a watershed overall, and how even though we're focusing on a freshwater ecosystem, our freshwater ecosystem still impacts the Chesapeake Bay and the ocean. Everything, again, with water and the environment is all interconnected. And so if we start small, even just individually or as a school learning about these fish, these indicator species, we can slowly make a change that's going to save us from having a really big problem to solve at the end. As always, any questions, please go ahead and email our Trout in the Classroom email address. And until I see you again, I'll see you in 2 weeks, where we're going to talk a little bit more about kind of the fish themselves and the hatchery and how we get them and kind of all of that fun stuff. So I will see you in 2 weeks. Bye.